Okay, here we are in Unit 3, Section 1. Your I can statements are I can find the least common multiple of two numbers. And if you see the letters LCM, that stands for least common multiple. And I can add and subtract like fractions. Go ahead and pause this video and get those I can statements in your notes. Alright, the least common multiple is the smallest number that a set of numbers will divide into evenly. That also needs to be in your notes. So we're going to consider the number 5 and the number 3, and we're going to discuss what are some numbers that both 5 and 3 will divide into evenly. And what we can do is we can start listing some of the multiples of both of the numbers and see what multiples are common to both. So here I go. I got 5 times 1 is 5, so 5 is a multiple of 5. 5 times 2 is 10. 10 is a multiple of 5. 5 times 3 is 15. 15 is a multiple of 5. So I'm going to just continue this list on down and list several multiples of 5 here. Now, 3 times 1 is 3. Then 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And I'm going to continue with the 3's. I'm going to list several multiples of 3 over here. Now, I got several multiples of each listed. Now I can just kind of see what's common to both. Look right here. I got 15 is on both lists, and 30 is on both lists. So both 15 and 30 are common multiples of 3 and 5. And if I continued to list, I would find some more. If I continued down with my list on the left side with the 5's and the list on the right side with the 3's, I would find that there are more common multiples. But 15 is the smallest number that's listed on both sides. So that means 15 is the least common multiple of 3 and 5. Now, I'm sure you don't want to have to list these multiples every time you're trying to find a set. You don't want to have to do this every time, so I got a different way that you can go about here. Instead of having to list the multiples of each one of these, I got a kind of a shortcut. We're going to try 75 and 30. Now remember, we're looking for the smallest number that both 75 and 30 will divide into evenly. So it's going to have to be bigger than 75, right? If it's smaller than 75, it won't work. Alright, I'm going to start by finding the prime factorization of all the numbers in a set. And of course, we've got two numbers in this set. We've got 75 and 30. So, if you'll remember from the previous lesson, prime factorization, 3 times 25 is 75. And then I can break the 25 down to 5 times 5. I'm going to list that as 3 times 5 squared. I'm going to do the same thing over here with 30. 3 times 10 is 30. 10 is the same thing as 2 times 5. So, I've got 3 times 2 times 5. Or 2 times 3 times 5, list them in order. Alright, the next step is to list each factor, but only once. So I'm going to take each one of these factors that's listed, and I'm going to just kind of put them down here in order. So I've got a 2, I've got a 3, and I've got a 5. That's the only only 3 different factors I have here. The next step is to choose the highest power of each one of them. Well, 2 is just to the first power. 3, both of those to the first power. But I have a 5 to the second power, so I'm going to pull that second power there. Now I multiply. And I end up with 150. So 150 is the smallest number that both 75 and 30 will divide into evenly. That's how you do it. The steps again are find the prime factorization. List all the prime numbers that are available to you, and then get the largest power of each of those. Then multiply them together. Now let's talk about adding and subtracting like fractions. The term like fractions means the fractions have the same denominator. You want to put that in your notes. Like fractions have the same denominator. Alright, so I have 4 over 5 plus 2 over 5. When adding like fractions, you just find the sum of the numerators and leave the denominator unchanged. So this is pretty simple. I add 4 and 2 and get 6, and I leave the 5 alone. Don't forget you got to simplify, so 5 will go into 6 one time with a remainder of 1, so I have 1 and 1/5. What if this was a subtraction problem? When subtracting like fractions, just find the difference of the numerators and leave the denominator unchanged. So 4 minus 2 is 2, and then I'll leave the 5 alone. This one won't simplify. Alright, what if we have a mixed number to add or subtract? I like to deal with the whole number part separately, so what I'm going to do is take that 3 and that 2 and go ahead and add those together and get 5. Then I know that my denominator is going to be the same, it's not going to be changed, so the next step is to add the numerators. So 2 plus 4 is 6. Now when I simplify this, I got to add that whole number together. So what's going to happen is 5 goes into 6 one time, so I have another whole number here of 1. So I'm going to have to add that 1 to the 5, and then I got a remainder of 1. So I'm going to have 6 and 1/5 when I simplify here. Alright, the difficulty with subtracting a problem like this is that 4 is bigger than 2, so we have to borrow from the 3. What I have here, this 4 is bigger than this 2, so I'm going to have to borrow some. Alright, so you can take 1 from the 3, which makes it a 2, because I'm borrowing a whole number here. Then you add the denominator, you add this 5 here, to the numerator, to this 2, for a new numerator. Alright, but I still have to leave the denominator the same. So what am I going to do again? I'm going to borrow 1 from the 3 and make that a 2. I'm going to add the 5 to the 2 and make that a 7. Alright. Now I can go ahead and subtract the whole numbers. 2 minus 2 is 0, so my whole numbers are gone. And then I have 7 minus 4 is 3, so that gives me 3. And my denominator is unchanged, so it's 3 over 5. Alright, what I need for you to do now is complete this bubble map listing different types of fractions, and we've talked about several different kinds of fractions. You can look through your notes for some ideas, but you just want to fill in these bubbles. When you have fractions, there's different kinds of fractions. Just list them, and if you need more than 4 bubbles, that's fine. After that, I want you to write a brief explanation explaining ways that we use fractions in our daily lives.